In question 5B, you're given this diagram here, which is parallelogram, this ABCD. A circle passes through three of those points, A, C, and B. It also cuts the parallelogram at this point P. And the line CP is extended out to this point here, Q, which is where it meets the line that's extended from AB. The question is to prove that the length CD is equal to the length of CP, CD being this side of the parallelogram and CP being the line from C to the point P where the circle cuts this line AD. You're going to need your theorems for this one. Firstly, just remember that ABCD is a parallelogram, so the opposite lengths are equal and they're parallel as well. Secondly, this one here, the corollary 5, it's a little bit obscure and might not spring to mind immediately. It's that if ABCD is a cyclic quadrilateral, in other words that the four vertices of the quadrilateral are on the circumference of a single circle, then the opposite angles add to 180 degrees. And of course in this diagram ABCD is not a cyclic quadrilateral, but there is one in there somewhere, and I challenge you to find it. Firstly, this proof is going to take a huge amount of angle comparing, so to avoid a bit of any complication really, I'm going to use these symbols here, the dot and the circle, to indicate the size of certain angles and to say that they're the same, and later on I'm also going to use an X. So first of all I'm going to say the angle ABC is equal to the angle PAQ, that's this angle here is equal to this angle here, and that's because AP and CD are parallel. They have a common line, this QB, so therefore those two angles are corresponding. Similarly, the PCB is equal to QPA, and that's denoted by a circle, so that's this angle is equal to this angle, again for the same reason that these two lines are parallel and they have a common line, so those two are corresponding angles. Next I'm using theorem 6, the exterior angle theorem, which says that each exterior angle of a triangle is equal to the sum of the interior opposite angles. So this angle here, CPA, is equal to the sum of those two angles. And I'm going to replace this angle PAQ, since that's a dot, I can replace it with this other one, which is a dot. So it's a sum of a dot and a cross, and I'm saying it's just those two beside each other means it's a sum and not a product. Next I'm saying that these three angles here add up to 180 degrees. Well actually I'm replacing this PAQ with ABC. Remember they're both dots, so they're equal in measure, and so they're interchangeable, at least in terms of sort of the measure of the angle. Secondly I'm saying that this angle CPA plus ABC is equal to 180. That comes from corollary 5, the opposite angles of a cyclic quadrilateral add up to 180 degrees, and of course this is a cyclic quadrilateral ABCP, so I'm able to use that. Secondly I'm going to use what I have back here, that CPA is equal to PQA plus ABC. I'm going to replace the CPA here with those two. Again, it's splitting up this dot and cross into a dot and a cross separately added up. Now I know these three angles add up to 180 degrees. Also these three angles add up to 180 degrees, therefore this sum is equal to this sum, and that's what this line here is. And again, just a bit of clarity, I've put the symbol I'm using for each of these angles over them. So I'm saying the cross plus the dot plus the circle is equal to the cross plus the dot plus another dot. So I've got a cross on each side, so they'll cancel out. I have a dot on each side, so they'll cancel out as well. And what I'm left with is that the circle is equal to the dot. Very last bit then is to say this DPC, that's this angle here in the diagram, is equal to PCB, because they're alternate angles. Remember CB and DA are parallel and they have this common line PC. They're also equal to ABC because PCB is equal to ABC, which I already said. Secondly, I know that PDC, that's this one, is equal to ABC, which is here, because they're opposite angles in a parallelogram. And because I know that ABC is equal to PCB, I also know that PDC is equal to DPC. That's that this dot is equal to this circle. So by the converse of theorem 2, that is the two angles in the triangle are equal in measure, therefore the triangle is isosceles. And since the triangle is isosceles, I also know that two of its side lengths are equal as well. And it's the two sides that the angles don't have as common. So these two angles have the side DP as being common, so it's the other two sides DC and PC that are common. And that's what you're asked to prove right at the start, so that is the question finished. If you were so inclined, you could also prove that this line here, PC, is equal in length to AB because you're getting two similar triangles here, QBC and QAP are going to be similar. And since the two angles are equal, then you know that you're going to get, again, two equal side lengths. So you can prove that PC is equal to AB because not only is the big triangle isosceles, but also because it's similar to this one. And then you say that the DC is equal to AB because they're opposite sides in a parallelogram. Therefore, DC and PC are equal in length as well. It's no harm when you see a question like this just to put in as many of these dots and crosses and circles and things as you can. Just in the first few minutes of the question, and only put down, of course, the ones that you're absolutely sure about. For example, you can't say that these two angles are equal immediately. It comes from all the other stuff that you can tell immediately, that these two are equal and that those two are equal, and this here is the sum of those two, and that kind of thing. It'll make your job a lot easier just to get that in a diagram right as soon as you start the question. And possibly even to say that lengths, or whatever lengths you know, are equal. So for example, that length and that length are equal, that length is equal to that length, and they're also parallel, that kind of thing. It can cloud your diagram a little bit, so maybe do it in pencil, and but it will genuinely help if you're doing any kind of theorem question like this.